Hello everyone, welcome back to part number 2 of practical number 4. So title of this practical number 4 is development and execution of program in C for study of logical operators and data conversion. So we studied the first 4 programs, program 1, program 2, program 3 and program 4, and 2 programs are remaining. Okay, that is program number 5 and program number 6. Okay, so in this part we will cover this program number 5 and 6. So program number 5 is write a 8051C program to perform checksum operation to ensure data integrity of data. Okay, so these data bytes are given, okay, of which data integrity we have to check. Okay, so these bytes are received at the receiver end. So these bytes, total bytes are 1 2 3 4 5 6. Okay, and from these 6 bytes, first 5 bytes, these 1 2 3 4 and 5 bytes are data, and last byte is checksum byte. Okay, so at the receiver end we have received this 6 data bytes, and we have to ensure data integrity, means correctness of this data, okay, by using this last byte, that is checksum byte. For that, what we will do, we will add all these bytes. Okay, while adding we will ignore carry that will get generated, and in the end a result in a byte. Okay, so that should be equal to 0, then we can say that that data is received correctly. Okay, otherwise if that sum is non-zero, then there is a problem in data, and we have to again transmit and receive this data. Okay, so after checking data integrity, if we find the data is good, we have to display ASCII character G, okay, on port 0, and if that data is not good, then we have to display ASCII character B on port 0. Okay, so this is fifth program. Next, last program, program number 6. Write a 8051C program to convert 1111111101 binary data, okay, or in hex FDH. We have to convert these to decimal equivalent, display the digits on ports P0, port 1, port 0, port 1 and port 2. Okay, so let us start with program number 5, that is already written and I have opened it. Okay, so this is program number 5 to check data integrity of data given. Okay, so as usual, hash include reg51.h void main void. Okay, and this is the main program enclosed in between this opening brace and closing brace. Okay, so first unsigned char my data. Okay, my data is a unsigned char type of variable. Okay, in blank square bracket equal to between opening and closing braces, these are the data bytes or elements of this my data array. Okay, so these are the data bytes given of which data integrity we have to check. Okay, first byte is 0x22, second is 0x76, third is 0x5e, fourth is 0x8c, fifth is 0x99, and last one, that is 0xe5, which is a checksum byte. Okay, so at the receiver end we have received this data and we have to check its integrity. Okay, so this data is stored in my data array. Total 1 2 3 4 5 6 6 elements are there in my data. Okay, next we are declaring two variables having name x and checksum of type unsigned char. Okay, while checksum variable is being initialized with initial value 0. Okay, next what we have to do, we have to add all these bytes. While adding we have to ignore carry that will get generated. Okay, for that I have to use for loop. It will repeat for 6 times. Okay, and in each pass one element, okay, starting from first element of this my data array, that will get added into checksum. That is checksum is equal to checksum plus my data in brackets square bracket x. Okay, for x is equal to 0, x is less than 6, x plus plus. So x is initialized with 0. So in first pass what will happen, So my data in square bracket x means x is having value 0. That is my data in square bracket 0. It is referring to first element that will get added into checksum. Initially in checksum we have value 0. Okay, so that first element will get added into checksum and that will get assigned to checksum. Means in checksum, okay, we will have value 0x22 in first pass. In second pass, x will get incremented by 1. So continuation of loop condition will be checked. X is less than 6. It is true. Again, these loop statements of this for loop will be executed. Checksum is equal to checksum plus my data in square bracket x. Now x is having value 1, means it is referring to second element in this my data array. Okay, so that will get added into checksum, whatever value in checksum. Right now we have value 0x22 into checksum, so into that 0x76 will get added, and that sum will get assigned to again checksum. In this way, all these elements in my data array, okay, will get added. Okay, and in the and next when this uh, for loop ends, then statement below is if statement. If checksum is equal to 0 means value in checksum variable. Okay, if it is 0, that means sum of all these elements in this my data array, that is equal to 0. That means data is good. Then to the port 0 I am assigning ASCII character G, indicating that the data received is good. Okay, so P0 is equal to in single quotes G semi comma, that will output ASCII code of G, letter G to the port 0. Okay, and if checksum is not equal to 0, then B later will get outputted to port 0. Okay, so that is asked in the program. Now I will build this program, so there are no errors. Now I will debug this program. Okay, so see here first. Okay, so I will use step execution. Okay, so now this for loop will be repeated how many times? 6 times. Okay, so first in checksum, first element will get added 0x22. In next pass, second element will get added. So sum in 22 plus uh, that is 22 plus 76, that is 98. Okay, so in checksum 98 is there. Next third element will get added. Okay, fourth element will get added, fifth element will get added, and sixth element will get added. After that, control will come out of this loop and go to the next statement. So see the value in checksum value is 0 0. That means data is good. Okay, so here we are checking whether checksum is equal to 0. If it is 0, what will happen? So this statement will get executed, that is ASCII code of G will get outputted to port 0. Okay, so here view I will view port 0. Okay, so I will check whether the ASCII code of G will get outputted on port 0. Okay, yes, that is being outputted. ASCII code of G is 47. Okay, so that will get outputted. And if sum in this checksum variable, okay, if it is not 0, then B, ASCII code of B will get outputted to port 0. Okay, in this way we can check data integrity of data received in the receiver end. Okay, so this is the fifth program. So now we will go to the next program, that is program number 6, sorry. So I will add that program number 6. Okay, close program number 6. Okay, so this program convert is written to convert binary or hex number to decimal equivalent and display that decimal equivalent. Okay, so one byte uh, of hexadecimal number of binary number. Okay, that will have maximum decimal value 255. So there are 3 digits, and to display these three digits we require three ports, port 0, port 1 and port 2. Okay, so that's why here uh, display the digits on ports P0, P1 and P2 is asked. Okay, so we have to convert this 1111 1101 in binary or FDH number to equivalent decimal. For that, program is written. See, okay, so as usual, hash include reg51.h void main void, and this is the main program between opening and closing braces. So here unsigned char bin byte is equal to 0xfd semi comma. So that number given, binary number or hexadecimal number. Okay. So that is stored in bin byte type of variable of type unsigned char. Okay. Then we are declaring four more variables of unsigned char type to to convert that hexadecimal or binary number to equivalent decimal. Okay, x, d1, d2 and d3 are declared as unsigned char type of variables. Now the program, first x is equal to bin byte divided by 10. Okay, so here first what is done here, x is equal to bin byte divided by 10 means whatever bin byte, okay, that is 0xfd. So in decimal I think it is a 253, in decimal it is 253. Okay, so that will get divided by 10. Okay, but x is unsigned char type of variable. Okay, it means it cannot hold fractional number. Okay, so 10 divided by 10 divided by bin byte divided by 10, that is 253 divided by 10. Answer, actual answer is 25.3. Okay, but only the integer part of this number, that is 25, will get assigned to x. Okay, means after this what will happen? So in x we will have 25 number. Okay, next d1 is equal to bin byte percentage. Okay, modulus 10 means remainder after division. Okay, means bin byte will get divided by 10 and whatever remainder is there, that will get assigned to variable d1. Okay, so what is value in bin byte? 253 percentage 10. Okay, so that will, I will get 253 divided by 10, that is a 25. um, okay, and remainder is 3. Quotient is 25, remainder is 3. So answer of this 25% d is 3 and 3 will get assigned to d1. Okay, next what will happen? D2 is equal to x percent 10. Okay, so x percent 10 means what? X is having value 25. X is having value 25. So 25% 10. Okay, means remainder after division. If we divide 25 by 10, okay, 10 twos are 20 and remainder is 5. So 5 uh, will be remainder and that will get assigned to D2. Okay, that means in D1 we have 3, in D2 we have 5. Okay, and in a D3 is equal to x divided by 10. Okay, so x is having value 25 divided by 10, that is equal to 2.5, isn't it? But here D3 is unsigned char type of variable, means only integer part of this number will get assigned to variable D3. Okay, so D3 will have value 2. Here D2 will have value 5 and here D1 will have value 3. Okay, so in this way answer is D3, D2, D1, means D3 is digit number 3, D2 is digit number 2 and D1 is digit number 1 of equivalent decimal number. Okay, so in this case D3 is what? D3 is 2, then D2 is a 5 and D3 is uh, 3. D1 is 3, sorry. Okay, that is 253. That is nothing but decimal equivalent of 0xfd. Decimal equivalent of 0xfd is 253, isn't it? So that in D1, D2 and D3 we have that decimal number. 253, that we are going to display on port 0, port 1 and port 2. On port 0 we have displayed least significant digit of that decimal number. On P1 D2 digit is displayed, and on P2 D3, that is most significant digit of the decimal number 253 is displayed. Okay, so this is the program to convert that hexadecimal or binary number given into equivalent decimal number. Okay, now I will check for errors. I will build this 0 errors. Now I will debug the program. Start. Okay, okay, so I will display port 0, port 1, port 2, port 1 and port 2. Okay, so here port 0 will have D1, that is so this will have most significant digit. Port 0 is a list. Okay, and okay. Okay, so now I will run the program and see. Okay, so this is 2, this is 5 and this is 3, 253. Okay, so this 253 decimal converted number is being displayed on port 0, port 1 and port 2 as it is asked in the program statement. Okay, in this way we can convert given hexadecimal or binary number into equivalent decimal number. Okay, so this is the program and this is the output. Okay, so this is about the programs on this in this practical number 4, that is development and execution of programs for study of logic operators and data conversion. Okay, so I think this much is sufficient. So I have posted write up of this practical number 4. You can proceed writing that, but you have to refer to these programs actually we have studied. Okay, and these programs you have to write into your journal. Okay, not the program that are written on the write-ups I have sent to you. Okay, so any doubt you can contact me on WhatsApp or my mobile number. Okay, so I will stop here.